Thank you, Wendy. Appreciate that. Hi, everyone. My name is Royal Casey. I work with Peterson Aluminum Corporation, also known as PacClad. I'd like to start off by just thanking AIA Florida, first of all, for putting on this webinar. We get a lot out of it. It's a great opportunity for us to get this material out in front of a lot of people at the same time. So thank you to Wendy and all the folks over at AIA Florida. I'd like to start off with just a brief description or past of mine and how I got here. I've been in the metals industry 21 years now. The first 10 and a half years I was on the contractor side of things. I did everything from install to fabricate to project manage and estimate there kind of at the end of my tenure there as a contractor. So I've worked with every major metal manufacturer out there on the contractor side of things. I know their warranties inside and out, and just know how their systems go together. Kind of a natural progression for me. I got onto the manufacturing side of things. After that, worked with a different manufacturer for a little over 3 years before Peterson, and been with Peterson coming up on 8 years now. So all I've done is metal. Even on my contractor days, we specialized in metal. We didn't really do any other type of roofing or wall panels or siding or anything like that. It was all pretty much metal. So that's really all I know. So if you have questions, after this webinar, please don't hesitate to reach out. But let's jump into it. Like Wendy said, there's a question and answer tab somewhere there on your screen. You can throw some questions in there, and I'll if I get a lot of questions, I'll try to start answering them as they come in, or maybe at certain times of the presentation. But go ahead and throw them in there. If not, I'll wait till the end and kind of clean them up there. But I think they'd like them to go into questions and answers and not the chat room. So jumping into this, obviously, Peterson Aluminum. We're going to be talking about metal wall panels in general, and some of the differences, the corrugated and concealed fastener type systems. Obviously, you're going to get some AIA credits for this. That'll all go through AIA Florida, and Wendy will take care of all that. But this is an accredited presentation. It's also a copyrighted presentation. Happy to share it with you all. I think, like Wendy said, it'll be uploaded in the chat and then sent out later, or in the questions and answer, I'm sorry, and sent out later to you as well. Just remember, it's only intended to be used for what it's supposed to be used for. Okay, so some of the advancements in the metal wall panel with the different profiles that we offer is going to be kind of some of the stuff we talk about. Used to be kind of a lot of face fasten stuff. Now we have concealed fastener type panels. We're going to be talking about some of the details, the do's and the don'ts. Talking about the effect on the environmental efficiency and project sustainability and product performance. Very critical, some of these learning objectives that we're going to talk about, the performance requirements, right? Putting up the right panel in the right environment and the right application. We need to work these out early on. And that means really incorporating the structural engineer of record and getting those wind loads. So we know what type of profile, what type of system, what type of material to be used. And then also the devil's in the details. You hear that kind of stuff all the time. So same thing with metal wall panels. If we don't lay it out and use the right details, we can have leaks basically. So we want to review the wall elevation conditions during D&D and CD stage. We want to apply those S notes and structural engineer of record early on. And again, make sure we're using the right systems. We want to make sure what we're attaching to the framing members are at the correct spacing, before, the building starts going up. We want to get with the framer and make sure they're putting them at the right spacings. We also want to make sure we're laying these wall panels out correctly. Where's that seam going to land when it comes to a penetration or to, to a detail, a window, anything like that. We want to make sure we're asking these questions early on and talking about them early on. And then we're going to talk a little bit about some of the problem areas, right, where we interface with other trades or other types of materials and how to do that properly. Big one for me here, is Guantanamo Bay is a coastal application here. This is salt water right there underneath the wall panels. And unfortunately on this job, they use steel. And in about 10 years, this is what it looked like. You can see the bottom of there is just completely rusting out. The framing members, I'm sure, are just as bad as the wall panels. But, I'm going to kind of harp on this as we go through that aluminum is the way to go whenever we're near any salt water. And when I say saltwater environments, it's any type of salt water, right? It's brackish water. It's not just being right on top of the ocean or the Gulf. It's those brackish rivers that have salt content in them as well. If you read your warranties, you have to be, depending on the manufacturer, you have to be at least half a mile to a mile away from any body of salt water. Again, not just the ocean, not just the Gulf, but any body of salt water, brackish included. Because this is what happens, right? This is up in the panhandle here, and this is just a coping detail here, right? Not much metal on this job except for the coping, but they use steel. You're generally going to see it where there's a cut edge, right? Where there's laps is where that raw edge of metal is going to start to rust. And this could have very easily been avoided by using aluminum material in this type of environment. Again, a bit of a pet peeve for me, and making sure we use the right material. Here's the other one where we talk about, the framing members. These are not only the wrong size, they're too small, right? That clip that holds the panel on requires 2 fasteners in it, and this structural member only allowed room for 1 fastener. So we're half of the performance there, right? Not only are they too small and not big enough for the clip, but they're spaced too far apart for this type of application, right? We're talking about that looks like about 7-8 feet. And in Florida, you're never going to get away with that kind of stuff. So unfortunately, this was one where we got kind of brought in late. We saw this and said, whoa, stop. We need to take all these panels off, make sure we have the right framing members behind it. And it just didn't come up in the conversations early on. They waited too long to really start talking about where these framing members should be. Another kind of touchy subject is oil canning. What you're looking at here is just a basic flush type panel. It's probably 12 inches wide. But real long runs, right? 35-foot long panels here. In one panel, that panel's it's not going to move as much as it wants to. And where does that movement go? It goes to the flat of the panel and ends up being what we call oil canning. And this will move and be smooth part of the day. And then when the sun hits it, it starts to expand and contract and gets this type of a look to it. Nobody wants to see this type of a look. It's not really a cause for rejection. The performance wise, the panel is still performing. It's just not able to expand and contract, or it's moving a little too much. So what do we do to help prevent this? One would be is to break these panels up. This is just a suggestion here. These kind of dashed lines you see, tying it into the window mullion. You kind of make it look like it should be there, but we could have cut these panels in half and probably reduced a lot of this oil canning. So flashing brakes to shorten the panels. You can also do things, you never get rid of all oil canning, but you do things to help reduce it. One thing here would have been stiffening ribs in the flat of the panel, just very minor bends in the flat of the panel to help stiffen it up. You can also increase the gauge. Let's just say this is 032 aluminum. maybe we wanted to go to 040 aluminum. Again, the thicker, stronger material is less likely to oil can as much. But again, this is just something that needs to be brought up early on, that these panels are 35 foot long. That's, above and beyond the manufacturer's recommendations. So let's get with the manufacturer. Let's try to get with maybe an installer that you know well, and ask these questions. Can this be done? What's it going to look like when it's done? If somebody would have called me on this and said 35-foot panels, I would have said, no, we need to break these up. Let's make them, 17 feet, 18 feet long, put a flashing brake in there, and would have helped reduce a lot of this. Again, things like pencil ribs and increased gauge would help as well. Avoiding kind of these old details. I know back in the day that people wanted to see that seam come right off the roof and down into the fascia or the wall without any type of break. They tried to use these knuckle details at the seam, and this is what happens with those. It's just really a bad detail. You're pinning that roof panel up at the ridge. It's expanding towards the eave. Now you cut the seam, turn the panel down on the wall, and attach to the wall. So essentially now it's pinned at the eave, and it's pinned at the ridge. So metal's going to move no matter what you do to it. It's going to want to expand and contract. So what it does is it really just tears that detail apart. And this is what it looks like. I don't know, 10 years down the road, this is what it looks like, and is probably leaking not enough to see inside the building, but enough to be getting in behind the panels and doing damage to the structure that the panels attached to. So again, this could have very easily been avoided, especially in this area where you have a flat roof. I don't think anybody even sees this area. We would have cut those panels, put a drip edge that covered over the wall panel, and then started the roof panel from there. Let the wall panel move independently from the roof panel. It would have had a horizontal line detail there, if you will, but would have been a much, better detail. All right, it's just kind of checking the questions here. There we go. Some things we can't really detail for. We can talk all we want to the structural engineer and the designers early on, but things like this, cars running into the buildings, unable to design for every human factor. So kind of is what it is. I don't know that this really applies to just metal. This is true with anything, right? Not much we can do with that kind of stuff. One of our learning objectives here, identifying critical performance requirements and key criteria that are important to the owner during D&D and CD stages. The thing here is, contacting your manufacturer. Maybe you have an expert contractor that you work with on a lot of jobs that you can reach out to and just say, hey, here's what I want to do. What do I need to do to make it work? Or do I need to change to a different profile? Should I be using a different type of panel? Just again, early on, reaching out to those manufacturers, or that trusted advisor is the way I like to describe it. Assessing the big picture, coastal applications. We talked about that, using aluminum in those coastal applications versus steel. Or high wind areas, right? Using the right panel. All these, obviously here in Florida, we have to test for either Florida building code or Miami-Dade building code. And we want to make sure that testing and those pressures will meet what we have on the building. We want to consider performance requirements such as building height and other performance criteria, the type of material we talked about, whether it can be a single skin type panel, or maybe it needs to be a composite type panel. We also have insulated type panels out there as well. Aluminum versus steel. When do we want to use that? Right here in the middle of the state. Say in Orlando, no problem using steel, right? But any of our coastal cities, we really want to start thinking about aluminum. You know, it might be okay, might be, let's just say Fort Lauderdale, but it might be inland enough and away from all these brackish rivers where we can use steel there. But I always kind of err on the side of caution and using aluminum in most of my coastal cities. But just needs to be a conversation. We need to make sure where we're at with the job and all that. Maximum panel lengths, right? We don't want to, especially like a flush panel, a really flat panel in the flat of that panel. You know, how long can we go with it before it's going to really start oil canning? And some of the limitations we have there. And then, of course, trade integration and collaboration, working with the mechanical contractor, the plumbing contractor, making sure where their penetrations are going to be versus where our panels are going to line up. Looks like we have a couple questions here. I'm going to go ahead since we're kind of changing gears here a little bit. Let's see, a question. If you cut, then creates moisture issues. Not sure exactly that question. Obviously, you know, positive water flow. If you cut a panel, let's say on the wall, and then you're tying the roof into it, you have a drip edge that covers over the top of the wall panel, and then you're starting your roof panel there. So that cut doesn't really cause moisture issues, is because we have positive water flow. Typically behind our single skin type panels, or even aluminum composite type stuff, we're going to have moisture barriers behind it. You know, it is metal, it will condensate, so we'll get a little bit of moisture behind these panels at times, but that's why we use vapor barriers and peel and stick underlayments and just a proper moisture barrier behind the panel. Hope that answered your question. So where's my building located? Again, using the right substrates for the right location. I told you I was going to harp on this. Aluminum in those coastal areas is key. These metal panels, whether it's a roof, wall, soffit, doesn't really matter. They're designed to last, you know, 40, 50, 60 years. And if we put steel in a saltwater environment, that panel's never going to last 40, 50, 60 years. It's going to last 10, 15 years. And you're gonna see some pretty aggressive rusting issues. So again, aluminum on coastal applications. And we also like to take that a step further. Even if they're concealed fastener type panels, we want to use stainless steel clips and stainless steel accessories with those aluminum panels, even though that clip may not be exposed to the environment. Like we talked about before, you get a little bit of moisture behind these panels. You use a galvanized clip with an aluminum panel and introduce salt water to that. And those dissimilar materials are really going to go together, and that galvanized clip is going to rust right through the panel. So not only aluminum panels, but using stainless steel accessories along with it. Let's talk about budgets. You know, metal is not the cheapest material that we can put on our buildings. So making sure that the building owner has the budget for metal. It's a wide range, right? Our single skin panels in steel and a standard color are relatively economical. But then if we, you know, I get building owners a lot to come to me and they want aluminum composite material, but they don't realize that it's, you know, anywhere from $35 to $65 a square foot. So we just need to have those conversations. You know, we have alternatives, like I said, single skin type panels, even those exposed fastener type panels can be very economical versus, you know, an insulated panel or a aluminum composite type panel. So, you know, making sure they have the budget for it. How visible is the area? Are we using metal just for the longevity of it, but we don't really see it? So maybe you do use a face fasten type panel there. So it kind of depends on how visible it is. How is it, you know, kind of a really point of contention on the building, or is it just, you know, something that we're trying to cover up an area? A lot of that will kind of can go into what profile that we want to offer. And then, of course, once we figure out what panel we want to use, then we want to start talking about the framing and the substructure behind the panel, and how to install that, where to install that, how often to install that. Is there a significant number of penetrations on the building? If so, are metal panels the right cladding system? I'm a little biased. I'm the metal guy, right? I like to put metal up everywhere, but buildings that have a lot of penetrations, maybe this isn't the right application to put up. So again, just kind of looking at all the different aspects here: penetrations, framing, types of panels. And then, of course, again, budget and can they afford it? What can they afford? Switching gears here a little bit and into some examples. I'm going to jump in the questions and answers here. Let's see here. What about the base metals used to manufacture the aluminum? Does the country of origin factor into this? For example, stainless steel has different base materials in different countries. So some stainless steel better than others. Absolutely. Yes. We've all had that stainless steel grill, right? That was outside for a couple years and rusted out pretty quickly because it's a very low grade stainless steel. We're definitely looking at that. I don't know how much the country of origin plays into that, but just really the type of stainless steel, right? Different grades of stainless steel. We use a very high grade stainless steel, marine grade, if you will, type of stainless steel. Next question was aluminum does pits. How are the panels protected against pitting? Well, with aluminum, it's painted. We really don't. You'll find some manufacturers out there that may do mill finish aluminum, but we don't like to do it. Everything that we do in aluminum is painted, so that's what's helping protect that aluminum, right, from pitting and all that. All right, let's jump back into this presentation. So here's a great example of kind of a retrofit, an existing building. Not really sure what kind of siding is on this building in the picture to the left, but we were able to strip it down. It looks like they replaced the windows as well. And then you can see the right hand side, kind of the finished product here, where we clad it with some metal panels. Again, replace those windows, put some wall panels up there, proper framing and attachment, horizontal and vertical. Panels can go, these panels could be run horizontally or vertically. Obviously those framing members behind it need to be perpendicular to the panel. And then using intentional panel breaks, right? We talked about the length of the panel not getting too long. Well, here's where we're able to break it up. That larger space on the picture to the right, if we were to go window to window, that might have been a little too far, is what I'm kind of guessing here for that panel and expansion contraction. So we're able to just break it up. We took the same width as the window, and that's where we kind of figured we'd put that trim break. So here's what it looked like once we tore it off. We put a basic underlayment on the building. You can see the Z channels here is what we're going to be attaching the panels to. Looks like these went horizontal, and then we had a cross member. You can see on the right hand side where we went, kind of vertical with the structural members, so that the panels could run horizontally. Different ways, different details for every different situation, right? So at the bottom picture here, where you saw that before, we put these intentional breaks here. Again, same width as the window, kind of made it look like it should be there. Maybe sometimes we don't want that. We want it to look continuous all the way through, where you can see on the top left-hand picture, where we're able to do more of like a splice break detail, right? So that's two panels, right, that kind of butt up to each other, and then they have a backer behind them, and has a little bit of gap there. Backer's the same color as the panels, but allows that panel to move. Uh, here's an example of a job and using different profiles on the same job. You have the bottom arrow is you're looking at a horizontal corrugated type panel. Then the middle one here is more of a flush type panel. And then of course you have a roof panel on top of that. So three different profiles on the same building. Structural engineer of record must be brought into the equation much earlier than we have in the past. We're seeing it way too much where we get there, the panel's already been picked, the framing's already installed, and we get there and lo and behold, the framing was put at 5 foot on center, and we need to attach it at 2 foot on center. So again, by bringing that engineer of record in early on, we can figure out what the framing needs to be before it goes up on the building. Just some examples of where the pressures of the building are located on usually one of the first, second, maybe third page of the structural drawings has the wind load pressures. Here's really kind of showing more of a roof pressures, zones 1, 2, and 3, and then below that you see 4 and 5, which are the walls. Just a little bit more of an example here of where to find those pressures. Then we go and get the Florida Proctor approval or the Miami-Dade. We look at the pressures, we look at what we achieved pressure-wise, and then kind of put those together, right? How often do we need to fasten this panel to the building? We've looked at a couple jobs here with the flush panel type panels. Here's realistic, for this job, 16-inch centers where we need to attach to for the soffit area and the wall panel area. So we're able to get those subgirts in there at the right spacings. By the way, the state of Florida requires us on our testing to have a 2.0 safety factor. So what does that mean? That means if I take that flush panel to the testing chamber, and let's just say I get 100 pounds of pressure, 2.0 safety factor tells me I'm allowed to use 50 pounds of pressure, even though I achieved 100 pounds. So always a 2.0 safety factor in the state of Florida. It used to be 1.65 for Florida, 2.0 for Miami-Dade and Broward. Now it's 2.0 everywhere. So just kind of that finished job, right? You see the panels kind of getting installed here, the proper framing behind it. Get some decent lengths in here. So I'm assuming we went with kind of a heavier gauge, but this is your traditional kind of flush panel type panel on the wall there, and the soffit. Again, some examples here, some really long runs where they didn't want to break up the panel as far as trim breaks and all that. So that picture I showed you earlier, we were able to do more of a splice break. And as you can see, if you really get up on it, you're going to be able to find those splice breaks. But like the normal layman being away from the building, they really kind of just blend in, and you don't see them if you're not really trying to point them out and see them. But great way to do these longer runs and make it look continuous without breaking the panel with a traditional trim piece. So yeah, just a nice looking job here. Here's what it kind of looks like going up. Your vertical framing, and then your panels being attached horizontally. Picture on the bottom right is more intentional breaks in the panel separated with trim pieces. Again, try to make it look like it's supposed to be there, so they lined them up with the windows to make nice easy transitions. So more than one way to do it. Some people like to see those line breaks as kind of might break up the wall panel there a little bit. Some people don't. They want to look continuous all the way through. When you're doing these splice type details, we always like to stagger those. If you put them all in the same line with each other, of all the panels are the same length, and they draw attention to the line. If they're staggered like this, it makes it flow through. It's kind of like almost like flooring, right? If you put down wood floor, you wouldn't line up all your joints. You would stagger those to make it look kind of continuous all the way through. So just something to think about there. I think this is always true with a lot of things in life, right? If something doesn't look right, it probably isn't. Let's investigate. Why is it oil canning? Why is it oil canning, right? If, the trim pieces aren't in the right places, it's not going to look right. So try to just use some common sense. If it's not looking right, it's probably something going on, maybe behind the panel, maybe some basic framing issues, some flashing details, could be a lot of things. Here's a big one. This is on the roof, but it's a good example of, metal is going to follow the substructure behind it. There's no way of getting around it. We can do minor shimming and things here and there, but when you have deficiencies like this in the structure, your panel system is just going to follow it. Whether it's the roof, the wall, doesn't really matter, right? You're going to have some ins and outs, and you're going to these type of things need to be fixed before the wall cladding goes on. Too many times I've come to a job and it's this type of framing behind it, and they went ahead and put the insulation on it. They put it whatever type of vapor barrier underlayment on it, and we get to the job and say, hey, guys, that's not going to look well. We need to take all that off, fix the substructure, and start fresh. We can only do so much to hide the deficiencies in the structure. And here's what can happen. This is an extreme example of oil canning, but this is what can happen when you have an uneven substrate. That is probably the biggest cause for oil canning, is an uneven substructure, right? If it has ins and outs and dips in it, that panel is going to want to follow it. These panels are made to kind of expand and contract like it's on a rail, right? You have to let it move. Now, if I have one clip that's not even with the other, right? It's down, the other one's up. It's not going to want to follow that substructure, so it's going to bind up. And where does that movement go? Because you can't stop the metal from moving. It's going to move. It's just going to go to the least path of resistance and go into the flat of the panels. When we're attaching to plywood, I like more attaching to a steel substructure. But when we're attaching to plywood, sometimes those clips can get too tight. And if you're in a dip and that clip is too tight, it's going to pin that panel and not let it expand and contract. And again, that oil canning goes to the flat of the panel. This is a little bit of an extreme picture here, but nobody wants a brand new roof or wall panels to look like that when it's all done. Penetrations coming through the wall panels is a big one, right? Any type of penetration, whether it's roof or walls, we need to detail that correctly. These penetrations is a tough one right here because they're all so close together. And how do we flash that? Not only a lot of small penetrations close together, but dissimilar materials. Copper, brass are the biggest ones, right? Steel and aluminum, yes, they're dissimilar materials, but they don't really react with each other. Copper, on the other hand, does. These pipes being copper coming out of this wall panel is going to corrode those wall panels, whether it's steel or aluminum. It's going to make just the contact with it is going to make it corrode and leak eventually. So we want to make sure that we can separate those materials for sure. What size of the penetrations, right? And what width is my panel? Where those seams need to be? These are some fairly large penetrations here. The square ones are typically pretty easy to kind of flash around. You're talking about L trims and J channels. Round is a little bit different. We want to make sure we're not going through a seam, that kind of stuff. Typically, these pipe penetrations, we cut around them as tight as we can. We caulk them in, seal them up temporarily, but then that's not the end sealing of that penetration, right? We need to have some type of either a boot or some type of flashing to cover up those sealants and that caulking. Exposed sealants and caulking, especially in Florida, right, are just going to dry rot and crack and become a leak eventually. If we use it between the metal or underneath flashings to help protect it from the elements, it will last a very long time. Here's a couple examples, a couple great examples, right? These are corrugated panels on the left here, and trying to go a corrugated panel around a round penetration. What they did is they picture framed it out here, gave me a nice flat substrate to seal that round penetration to the wall, and then just trim the panels out around it. It's called picture framing. The bottom right picture, more of the pipe coming through and then 90ing down. And we weren't able to get any type of real flashing around that. So we kind of just built this box around it, gave it positive water flow, and covered up those penetrations. So just some good examples of how to detail those areas. Just clean looking details. Again, the square penetration is a little easier to flash around. It's really just J channels and sill channels. Sill flashings, you have kind of a back-to-back J here, where they wanted to break the panel up. Just good clean looking detail there. Here's kind of a retrofit an old metal building that we were able to take the siding off and reapply new siding to it, new metal siding to it. Here's an area, I always laugh at this one. I think the thing here is they knew that this was going to take a little bit of damage. This is a tennis performance center. They kind of knew people were going to be banging into it, tennis balls and rackets flying around. So they wanted to use aluminum, right? If you get a scratch or something like that on an aluminum panel, no real big deal, right? It's not like steel. It's not just going to start rusting at that scratch and cause an eyesore. It's still going to be a scratch. We still want to repair it and touch it up, but the thing here is it's aluminum, so it's not going to rust just because it gets a scratch on it. This is one of my favorite pictures because they, again, wanted this to be a continuous look of these wall panels going all the way down. Obviously, this is a pretty long run there. So what we did is we used a back-to-back J channel, pretty traditional, just kind of flashing detail to break those panels up. And then we knew we were going to have a gutters and downspouts. So we located those downspouts right over where the flashing detail is. So when you look at this building, you see the downspouts, but those are really covering up that flashing detail and making that panel look like it's continuous all the way down the building. Just some more examples here. This is these red panels that you see here, obviously on the exterior of the building, and then they actually flowed through the building, giving a pretty unique look there, continuing that panel from the outside all the way into the inside of the building. And then you can see these details on wall panels are pretty basic. You're looking at outside corner trims, inside corner trims, J channels, and maybe sill flashings is the extent of your details. People tend to overthink them a little bit. And how do I do my flashings? It's really a bunch of J channels, corner trims. Just some more examples here, running these panels. This is the same panel here running horizontally in one direction, and then breaking it up there at the soffit line and going vertically with the same panel. Also, you can see where they tied the flashings in with the windows, right? Make those flashings look like they're supposed to be there. They just continue with the window. Nice clean looks here. All right, so let me jump into these questions again, see what we got up here. Can you share recommended details when cutting? I think I just kind of talked about that, right? When you cut the panel, for one, with steel and aluminum for that matter, you always want to use a shearing action, right? Whether that be hand shears, some type of shearing action on the machine that's making it. You never want to cut it with a saw, especially steel. You cut that with some type of a skill saw or saw, and you're going to leave a lot of raw edges, a lot of flakiness there at the end of the cut. I don't know if that's what you mean, but how do you cut it? Always with a shearing action, especially on steel. And then, the recommended details is, again, pretty basic J channels and corner trims. Let's see, can you use aluminum siding on steel framing? How do you protect the metals from each other? The answer is yes. Yeah, that's typically how it does get installed, right? An aluminum panel, usually the structure behind it, probably mostly for strength reasons, right? We're using steel behind it. Again, they are technically dissimilar materials, but those two types of material, it's not like copper and steel, right? Those react with each other very quickly. I mean, we're talking in days and weeks, it's already reacting with each other. Aluminum and steel don't really react with each other very quickly at all. That's, again, we're trying to give you 40, 50, 60 year projects here. And using steel framing and aluminum panels is fine. How do you separate that? Really, like I said before, aluminum panels are never mill finish. It's never just raw aluminum. It's either paint on the outside or even on the backside. It's like a primer or what we call wash coat. So it's enough separation there to help those two materials not react with each other. When possible, can you go back to the picture framing with the pipes? Can you clarify what the material around the pipes to prevent leaks? Yeah, I can do that real quick. Let's see here. So I think this is probably the picture that you were speaking about. So again, that round penetration, typically in this application, I think they're using some type of a flashing boot. So it's a neoprene or a rubber boot around that round penetration, but it's able to be flashed or attached. That rubber neoprene boot, if you will, is able to be attached to a flat piece of metal, right? If it's corrugated, that rubber boot or that neoprene boot will, kind of form to the corrugations, but it's a lot harder to make that do that and seal properly. So we want to give it a nice flat area for that boot to cover there. If and when we can't do that, that's when you see the picture to the right, right? Let's just cover the whole thing, keep the, probably caulked and sealed it as best we could to the panels, and then we built this box around it and flashed it properly so you have positive water flow, and then covered up those penetrations. Hopefully that answered your questions there. Oh, went the wrong way, sorry. So change gears here a little bit, understanding the importance of key basic details and layouts of these field flashing details to provide the owner the desired watertight and aesthetically attractive completed metal wall panel system. Again, I kind of go back to what we were just talking about, right? I'm always thinking performance first, right? I got to make sure that it's not going to leak. I got to make sure that it's going to last a long time. And then I kind of go in the aesthetics of it as well. Again, got to make sure it performs, but I understand it also has to look good too. So making sure we use performing details, but then, trying to keep them most aesthetically pleasing as possible. The proper flashings at the proper place. I see a lot of times where people, let's just pick on a window, right? Square penetration, fairly easy to detail around, but we want to make sure we have positive water flow, right? So I see the biggest mistake I see is people would use a J channel all the way around that window, and they'll just tuck the wall panel into that J channel. It's just to cover up the edge of the panel, right? But what happens at the top of that window, right? The water starting from the top, it's working its way down. And now you have a J channel, to me, that is really just looks like a gutter. It's just going to hold water and debris and dirt and everything else in that J channel. So what we want to do is use those J channels on the sides of the window and at the bottom of the window. But actually at the top of the window, we want to use more of a sill flashing so that you have that positive water flow or that positive drainage, and it's not just holding water. I see it way too many times, that J channel at the top of the window. They even do things like, drill little weep holes in it so the water can get out. That's all fine and good. It's still going to hold water in there. It's still going to get debris in there. That dirt comes out of those weep holes and runs down the window or the walls, making it look pretty ugly. So using the right details in the right place is huge. Look at additional items that can be placed sparingly on the walls, right? We don't always want a ton of penetrations. These non-exposed fastener panels are much like standing seam, right? The panel's never going to leak. It's the details, it's the windows, it's the round penetration. So the less details we can have, the better. Obviously, we all want windows and things like that, but trying to get those penetrations going out the right places. Maybe the roof's a better place for that penetration than the wall. And, we always like to talk about metal is 100% recyclable, right? Life cycle to easily last 20 years. You've heard me say it a couple times. It really should be lasting you 40, 50, 60 years. But the point is here, after 40, 50, 60 years, when we do need to replace it, that material doesn't just go to the landfill. We're able to take that to the recycle yards. We're already using a lot of recycled materials in our steel and our aluminum. And now here at the end of its life cycle, we still can put it right back into recycle and use it again. Here's kind of another pet peeve, right? We go to a job, we do the job, we finish the job, and then the building owner a year later wants to put a sign up. Where do they go? Oh, let's put it on the roof. And then they have, a sign manufacturer go up there and install it. To me, that's the wrong way to do it. I get it. You want your sign, that's fine, but consult the metal manufacturer, consult, a metal contractor on how exactly to do that. Don't let, your sign guy go up on your roof and start poking holes, because here's what happens, right? They find that framing member. They basically just bolt right through your panel. They probably put a little bit of whatever that black substance is right there below it to try to help seal it. But again, they're just trying to get their sign up and get off the job, and not really thinking like a roofer and relying on exposed caulking and stuff like that to keep this sealed up. So the point here is really to consult your manufacturer, or again, some type of contractor that specializes in the metal. Here's another one where you see the copper ground for this sign. Copper, again, in metal, whether it be steel or aluminum, those type of dissimilar materials react with each other very quickly, and should be avoided at all costs. I've even seen where they put air conditioning equipment up on the top of the roof, and just that copper pipe, the condensation where that lets the water out, just not even the copper touching the metal, but the water going through the copper pipe and dripping onto the metal is just like putting the two metals together touching. It will corrode and yeah, it would just corrode that material, whatever it's touching or even dripping onto. Signage is okay. We know certain companies want to put their signs up on their buildings. Just consulting us first. Sometimes with signs, we need to put more of a structure behind it for, to support the sign. And then making sure those penetrations through our metal panels are correct and not going to leak right behind the sign, right? I always say there's two types of leaks. There's a type of leak that pours in your building and you're, oh my goodness, I have a problem here. And there's the ones that you don't see. Those are probably worst, right? So these signs go up there and they put some goop on it, some caulking on it, whatever. But then it leaks just ever so slightly, which can degrade the framing behind the panel, not only the panel, but the framing behind the panel. Then you have maybe some type of a wind event where those fasteners holding that sign up are just corroded and rusted out. Or, if it's plywood behind it, that plywood doesn't have the structural support that it needs. So signs are okay, just need to talk about it first. Here's a great example. 80-year-old structure. They wanted this concrete kind of coping cap on top, so there's a lot of weight. So they had to add some structural support to this wall to help hold it up, right? This is the back side of the wall. Again, kind of goes into those questions of are you going to see the roof? Is that what's important to you? This where you're not going to see the roof, so the aesthetics of it aren't as important. right? So we can use a more economical panel, but these penetrations are big. You can see on that right-hand picture where the those penetrations were lined, or the wall panels really lined up perfectly to be able to flash. See how the top of it is more like a sill instead of a J channel trying to just cover the edge of the material, but having positive water flow as well. Just a good way, you know, these are kind of a roofing panel used on the walls and on the sun shade structures over the windows. So kind of used a couple different ways here, right? Used as a roof panel, used as a siding panel, and then used as a kind of a canopy type material. So yeah, just a good use of kind of breaking it up and using it in different ways. Some other ways you can break things up, right? Not only with color. This is actually the same profile. One was just rolled reversed from the other. So more of a low and a high, right? The high is more pronounced on the left side, the low is more pronounced on the right side. And then flashing it properly, back-to-back J channels here. Couple examples here. I'm going to kind of run through these a little bit. We're running a little bit out of time. Perforated type material here, used in a soffit application, right? They wanted it, the air to flow into that soffit. Well, when you lap these panels, those perforations never line up perfectly. So just kind of know that going in. Maybe you want to break that up with a piece of trim instead of just lapping the panels to make it look a little different there. Here's another perforated ceiling panel here, suspended to the structural framing. This is not the structural panel, but you know, here to help with sound deadening. So it can be used in so many different types of ways. A couple more examples of some perforating here. Thing to note with perforating, we only perforate aluminum. Perforate steel, and you punch that many holes in a steel panel, and it will rust within a year easily. Here's an example of just kind of an older building. This was a wall around the HVAC equipment, block wall, right? Not really just changing it out. So what did we do? We added a little bit of structure to it, structural members to it, and then attached a perforated panel to it as well, just to kind of, you know, we only did it on the top because that was only what was visible from the ground, but just gave this this building from far, gave it a kind of a different look here. Here's some parking garage type stuff, or parking enclosures, right? We want to let the natural light through. We're not really worried about keeping 100% of the water out. So it's perforated here, lets some light through as well, lets the air through, but gives that structure some more of an aesthetic look to it. Here's another one, more of a traditional enclosure for, you know, they probably have a lot of HVAC equipment up on top of this roof and they don't want to see it from the road. So they do this perforated panels above it. As you can see, those framing members are put just in the right places. You know, we can't span 10, 15 feet. We can only span 2, 3 feet. Couple more examples here, parking garages and how to just kind of jazz those up a little bit. I talked about the different types of material and all being recyclable. We separate them all in different types of materials they are. And obviously this is all our scrap when we're fabricating the different panels. And that's it. That's it. That's the end of my presentation. Thank you very much. My contact info, again, my name is Royal Casey, Peterson Aluminum. Here's my phone number. Here's my email if you want to write it down. Obviously, you'll get this presentation as well, either in the link. Let's see. It looks like I got 2 minutes. Let's see what other questions we have. Screws require special grommets and neoprene gaskets to prevent water penetration and aluminum damages. Please advise. Thanks. Yes, absolutely. Any type of face fastened panel needs to have some type of a neoprene washer there to help seal that penetration we're putting in the wall panel, right? We're screwing right through that panel into the subgirt behind it. So we can't just use your everyday fastener. Definitely have to use some type of neoprene gasketed fastener there. On the last slide, I don't know if I can, lastly, can you follow the presentation, some detailed illustrations? Yeah, I don't know exactly what slide we were talking about there. Again, with the details, getting your trusted advisor, whether that be a trusted contractor, trusted manufacturer, kind of working those details out early on. Let's not put the material up and then start talking about the details and how those are going to look. Let's talk about those early on. Shop drawings is a great way to do that, right? What is the time period required before neoprene gasketed screws need to be replaced? Great question. Great question. So yeah, you're relying on a little rubber washer that's exposed to the elements. They try to cover that as best they can with these fastener heads, right? We'll try to cover over those. But let's face it, it's just a rubber washer out in the the elements of Florida. It's going to dry rot and crack, and they're also, the way metal expands and contracts, those fasteners tend to back out a little bit. So I always say in about 5 years, you can go up there and you can tighten a lot of the screws, tighten them back down. And then every 10 years, you probably need to replace those fasteners. So about 10 years is the life of that gasketed fastener. The rule of thumb there is you take one fastener out, you take it to your fastener company. If it's a number 10, you want to replace it with a number 12. You always want to go up in thickness of that fastener, so that if there is, as that fastener backed out, if there's any rusting or corrosion around that penetration of that hole, now when we go in with the new fastener, we're kind of eating through that. We're getting a good attachment. Looks like we're